The oil sands face does not yield without a fight. The material here, a dense, dark mixture of silica sand, bitumen, clay, and water, is not loose. It holds together with a grip that changes character with the temperature. In summer, it is sticky and cohesive, clinging to everything it touches. In winter, it freezes hard, and you need something substantial to break it open. That something was an electric shovel. It is early morning, north of Fort McMurray. The pit is already in motion haul trucks positioned on the bench road, their engines running, exhaust rising in the cold air. At the face of the cut, an electric rope shovel is working. The crowd mechanism extends the dipper arm into the bank. The hoist cables pull up and back. The dipper teeth bite into the oil sands, loading a bucket that weighs more when full than most trucks weigh empty. The swing drive turns. The loaded dipper arcs over the truck body. The latch releases. In under 30 seconds, one pass is complete. 4 passes fill a haul truck. 4 passes is the standard. 4 passes is what keeps the trucks moving and the processing plant fed. The electric shovel was not glamorous equipment. It sat on its crawler tracks and worked the same face, pass after pass, shift after shift, powered by a cable tethered to the site's electrical infrastructure. But in the oil sands, it was irreplaceable. Nothing else could match its combination of digging force, reliability, and continuous output in conditions that destroyed lesser machines. Before we go further, if this kind of history matters to you, consider subscribing to the channel. Every video here is built around the machines and the men who ran them, the haul trucks, the shovels, the open pit, and oil sands operations that fed Canadian industry for decades. If that's worth documenting to you, the subscribe button is how you tell us, and we want to hear from you. Did you work in a Canadian mine, open pit, oil sands, underground, maintenance shop, processing plant? Did a father or grandfather drive haul trucks, operate a shovel, work the blast crew? Did you grow up in a mining town? Fort McMurray, Sudbury, Timmins, Trail, Flin Flon, or somewhere up in the territories? Leave it in the comments. The people who actually worked these operations know things that don't appear in any company report. We want to hear from them. Now, back to the operation. The electric rope shovel was not a complicated machine in concept. In execution, it was very large, very heavy, and very precise. A rotating upper structure sat on a crawler base. The dipper, a heavy steel bucket fitted with replaceable teeth, did the work of penetrating the oil sands face. The hoist cables controlled vertical movement. The crowd mechanism drove the handle forward into the bank. The combination of hoist pull and crowd extension was what gave the shovel its digging force. The entire upper structure rotated on a ring gear swing left to the bank, swing right to the truck body. That arc, repeated continuously, was the shovel's entire working geometry. The machines drew current through a cable from the site's transformer stations. This tether gave the machine unlimited sustained power without diesel complexity, but it meant the shovel could not move freely. Relocating a rope shovel, cutting the cable, repositioning on crawler tracks, reconnecting took time. In the oil sands, where pit geometry changed constantly as benches advanced, that was a real operational cost. The P&H 2800, introduced in 1969, with an initial dipper capacity of 25 cubic yards, represented the beginning of the large-scale electric shovel era in Canadian mining. By 1976, the 2800's dipper capacity had been upgraded to 40 cubic yards, enough to fill a 150-ton haul truck in 4 passes. 4 passes. That was the standard the oil sands industry ran on. Mining with electric shovels in the Athabasca oil sands was not the same as mining with the same machines anywhere else on the continent. The oil sands are approximately 83% silica, sand by composition, and silica is one of the most abrasive substances in the natural world. Tooth wear ran faster here than anywhere else. The replaceable teeth on the dipper cutting edge needed monitoring every shift. A worn tooth changed how the dipper entered the bank, reduced penetration force, and stressed the handle and hoist system. The bitumen complicated things further. In summer, when temperatures rose, the oil sands became stickier. Material that loaded cleanly into the dipper would not always release cleanly when the latch opened. Bitumen adhered to the inside of the bucket, building up over shifts. Winter presented the opposite problem. Below -20, the oil sands froze into material that had more in common with concrete than with loose earth. The crowd force required to drive the dipper into a frozen bench was higher. The motors drew higher current at startup in extreme cold. The lubricants ran thick until the machine had been working long enough to generate its own heat. The men who maintained these machines worked on schedules that did not stop for temperature. A blown hoist cable at -30 meant working in the open until the repair was complete. The shovel was either running or it was being fixed. The electric shovel operator did not get up and walk away between passes. The cab was small. The controls, joysticks, foot pedals, the swing lever were within reach without moving from the seat. The view forward looked directly at the bank being loaded and the truck body below. That view was the whole world for 12 hours. The shovel operator and the haul truck operator had to work together without being able to talk in real time. The truck backed into position on a signal horn blast. Light flash. A hand gesture from a spotter. The shovel operator judged truck position by eye, confirmed it was stable on the bench road, and began loading. If the truck was badly positioned, the dipper arc would not land correctly. Material would go over the side. Wasted load. Wasted cycle. 4 passes. 2 minutes from first bite to last. Dump in ideal conditions. An experienced shovel operator read the bank as they worked. The Athabasca oil sands were not uniform. Bitumen content varied bench to bench, face to face. A shovel operator who had been on the same machine for months knew when the dipper was hitting a higher grade zone by the way the teeth loaded the resistance, the weight coming up on the hoist, the sound of the crowd system working against harder material. That knowledge did not transfer easily. It was acquired on that machine, on that bench, in that pit. It stayed with the man who had earned it. The transition from draglines and bucket wheels to electric shovels and haul trucks did not happen overnight. Through the 1970s and into the early 1980s, both systems operated in the oil sands. The economic argument for shovel and truck built steadily. Losing 25% of production capacity to a single conveyor failure was a vulnerability the industry had been living with since 1967. An electric shovel working alongside a haul truck fleet was more robust. When one truck went down, the others kept working. When one shovel had a mechanical issue, the rest of the fleet continued loading. The system had redundancy built into its basic structure. By the early 1990s, Suncor had fully committed to truck and shovel mining. Syncrude followed in the late 1990s, retiring its bucket wheels and draglines as each reached end of service. The people who made that transition learned the new rhythm of 4 passes, truck out, truck in. The electric shovels of the oil sands era are not remembered the way haul trucks are remembered. The trucks had scale that registered immediately. The shovels sat in one place and worked, and their drama played out in seconds rather than in the arc of a haul road climb. What the shovels did was less visible, but just as consequential. They were the point of contact between the Athabasca deposit and everything that came after. Before the bitumen could be separated, before the upgrader could crack it into synthetic crude, before the pipeline could move it south, the oil sands had to be broken open and loaded into a truck. That work belonged to the electric shovel. The P&H 2000, 800S and Bucyrus Erie models that worked the oil sands through the 1970s and 1980s were not celebrated. They were production equipment. Some ran for decades in the Athabasca, before they were retired or rebuilt. A machine that survived 20 years in that pit had been maintained by people who understood it the way you understand a thing you have worked on every day for years. The oil sands are still producing. The deposit is still being worked. The electric shovels that made the first cuts into the Athabasca are gone. The resource they opened is not. If this is the kind of Canadian mining history you want to keep watching, subscribe to the channel. There are more machines, more sites, and more operations still to document. And if you have a connection to what you just watched, a family member who spent their career in a pit or on the patch, a grandfather who ran one of these trucks in northern Canada, someone who was there when this era of mining was still running, tell us in the comments. What did they operate? Which site? What do you remember them saying about the work? The men who ran these machines didn't leave many records behind, but the people who knew them are still here. We want to hear from them.